The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. Therefore, when you participate in the, got lost here. Participate in the Zoom meeting. If you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I'll respond as soon as I can. Even though it's Thursday, it seems like a Monday. Okay. Get this where I need it. All right. So we're going to take a look at some questions that people requested. Then eventually we'll get to section 2.6 part 1. I want to just remind people of the Math Center hours. I got an email last night at about 9:15. I responded just to say I'd talk about it today, but if you're looking for help in the evening, I suggest the Math Center. Here's the Zoom ID for that, just a reminder. Okay, now we are going to look at some questions. This is from section 2.5, number 7. And you can see the web assigned screen now. I believe I did that correctly.
Yeah, I can see it.
Okay, great. Just want to make sure. All right, problem number 7. It says a rock group plans to travel for a total of 20 weeks, making 3 concert stops. They will be in Japan for 2 more weeks, then they will be in Australia. Their stay in Sweden will be 3 weeks shorter than that in Australia. How many weeks will they be in each country? All right, so what do we know? We know there's a total of 20 weeks. And they're going to be stopping in, let's see, Japan, Australia, and Sweden. There is a comparison relationship developed between these 3 countries. It says they will be in Japan for 2 more weeks than they will be in Australia. So Japan is being compared to Australia. Then it goes on, it says their stay in Sweden will be 3 weeks shorter than that in Australia. So in both cases, in Japan and Sweden's cases, they're being compared to Australia. So whatever's being compared to, that's what we're going to have be represented by our variable. Okay. Now, go back, it says they will be in Japan. Okay. They will be in Japan for 2 more weeks than they will be in Australia. So Japan is Australia plus 2 weeks. Their stay in Sweden will be 3 weeks shorter than in Australia. So Sweden is Australia minus 3 weeks. Any question about how I got those relationships?
No.
All right. So what do we know? We know that the amount of time spent in Japan plus the amount of time spent in Australia plus the amount of time spent in Sweden equals the total of 20 weeks. So there's our equation. Simplifying the left side of the equation by combining like terms, x plus x plus x is 3x. 2 minus 3 is minus 1. So 3x minus 1 equals 20. We'll isolate the variable term by adding 1 to both sides. We'll isolate the variable by dividing both sides by 3. So x is 7. So x is 7. 7 plus 2 is 9. 7 minus 3 is 4. And these are all units of weeks. So Japan Japan is 9 weeks, Australia 7 weeks, and Sweden is 4 weeks. All right, let's take a look now at number 9. This is still in section 2.5. Number 9, it says 2 tanks hold a total of 44 gallons of a solvent. One tank holds 2 gallons more than twice the amount of the other. How many gallons does each tank hold? again, we have a total, and this time the total is what, 44 gallons. 44. One tank holds 2 gallons more than twice the amount of the other. So we have the one tank and the other tank. Now, one tank holds 2 gallons more than twice the amount of the other. So the one tank's amount is being compared to the other tank. The other tank is at the end of the comparison statement. So that's going to be our variable. One tank holds 2 gallons more than twice the other. So if this is the other, this is twice the other, and this is 2 more than twice the other. Any questions about that?
No.
All right. Well, what do we know? We know that the amount in the one tank plus the amount in the other tank equals the total amount, that is 44 gallons. So there's our equation. Simplifying on the left side of the equation, 3x plus 2 equals 44. Isolate the variable term by subtracting 2 from both sides. Isolate the variable by dividing both sides by the coefficient of the variable. And that's going to be what? 14. So x is 14. 2x would be 28 plus 2 is 30, and the units are gallons. Now, this is one of those things you have to be really careful of and read the directions very carefully. Notice over here in WebAssign, let's see if I can get this whole thing highlighted. It tells you smaller value, larger value. So I'll have students that'll put 30 in for the smaller and 14 in for the larger because they just didn't bother to read carefully. That's not the case here, but my point is be careful with things like that so that you don't have the right answers, but you switch them and then WebAssign marks them both wrong. And you're sitting there going, well, what have I done wrong? Okay. Anyway, let's go on and take a look at number 13 now. We're still in section 2.5. This is number 13. A cattle rancher is going to sell one of his prize bulls at an auction and would like to make $36,800 after paying an 8% commission to the auctioneer. For what selling price will the rancher make this amount of money? So the unknown is the selling price, right? Selling price. So that's going to be our variable. We'll call it X. Now, let's see, the cattle rancher that wants to make $36,800. So the selling price has to be $36,800 plus the 8% commission paid to the auctioneer. Okay, so they have to sell it for the amount he wants plus the auctioneer's commission. So the selling price has to be $36,800 plus 8% commission on what? On the selling price. Are we okay with this?
Yeah.
All right. So first of all, X on the left is the same as 1X, right? And I'm going to put the 1 there just to remind us of some things here. I'm going to get all the variable terms on the same side of the equation by subtracting 0.08x. If I take 1x minus 0.08x, I get 0.92x equals $36,800. Okay. If I divide both sides by 0.92, let's see here, 36,800 divided by 0.92, I get $40,000. So that is the price that it needs to be sold for. So then $36,800 will go to the rancher, and the $3,200, which is the 8% commission, goes to the auctioneer. Okay, let's take a look at 15B. So again, 2.5, number 15, part B. Let's see here. Show A and Show B are two of the most popular television shows of all time. It's interesting. I'm looking here. It marked part A correct, and technically it's not correct. Interesting. Well, anyway, we're going to do the whole thing. So, Show A and Show B are two of the most popular television shows of all time. The number of episodes of each show are consecutive even integers whose sum is 570. Okay, so consecutive even integers, the first one would be x, the next one would be x plus 2, right? Let's see, whose sum is 570. So that means x plus 2 equals 570. Okay. If there are more episodes of Show A, how many episodes of each are there? Okay, and this is kind of like a problem I did yesterday that I talked about how I got it wrong the first time I did it because I didn't read carefully. Show A has more episodes. So this is going to be Show A, and this is going to be Show B. All right, because Show A has more episodes. Let's go back and solve our equation, combining like terms. 2x plus 2 equals 570. Subtract 2 from both sides. 2x equals 568. Divide by 2, x equals 280. Let's see. 284. Okay, yeah, that's right. Oops, of course I didn't write that. 284. So then x is 284 and, or a, well, x and x plus 2 is 286. So Show A, 286. Show B, 284. Yeah, I'm not sure why it marked Show A correct, but anyway. Going on, problem number 16. The three numbers of the combination of a lock are consecutive integers and their sum is 36. Find the combination. So three consecutive integers, x, x plus 1, x plus 2. Their sum is 36. So x plus 1 plus x plus 2 is 36. 3x plus 3 is 36. Subtract 3 from both sides. 3x is 33. Divide by 3, x is 11. X plus 1 is 12. X plus 2 is 13. Now, here again, notice it says over in WebAssign, they want the smallest value first, then the middle value, then the largest value. So if you put 13, 12, 11, you'd get two of them wrong, even though you did find the numbers, but you've got to follow the directions given there. Okay. All right. So now we're going to go back to just the whiteboard screen. Okay. And we're going to get started in section 2.6. We're going to spend 2 days in it, and hopefully today I'll remember that. I won't zip ahead and do both sections at once. Okay. So first of all, I want to look at some tables. Okay. And let's see here. Draw this table. Okay. Here. Let's see here. Okay, it's going to take me longer to set this up than to actually do it. All right, we've got P times R times T equals I. And this says bank. And this says stocks. And over here it says total. Okay. So this is based on the formula I equals PRT, interest equals principal times rate times time, the simple interest formula. And we're given the following information. It says a man made 2 investments that earned a combined annual simple interest of $280. Complete the table and then form an equation for this investment problem. Okay, now, in this case, they already give us the following information. And that, this is a 1, this is a 1. All right. I want to explain, even though it doesn't ask, I want to explain where that information came from. The amount invested in the bank is X. The amount invested in stock is 6,000 minus X. And what I want to do is I want to look at how that works. Let's say that I had $6,000, okay? And I was going to invest it 2 different ways. Let's say that I was going to invest $1,000 here and the rest there, okay? Here, we'll call this here and there. So I've got $6,000. I'm going to invest $1,000 here and the rest there. How much am I going to invest there? Can you tell me, or do you want me to?
5.
Okay, so this would be $5,000, right? Let me ask you this. How did you get that $5,000?
Because if you have a total of 6 and you're gonna invest 1,000 over here, then the rest would be 5, right?
But why is the rest 5? You restated the facts, but where did you get the 5? How did you get it?
By taking away 1,000 from the 6,000.
Bingo. That's
Yeah.
what I was looking for. And so, and I know it's like, well, what? It's 5. You know it's 5,000 because you could easily say 6,000 minus 1,000. My point is, this is 6,000 minus $1,000, right?
Yep, right. Yeah.
At which point you go, well, duh, that's $5,000, right? Okay. But what I want to look at is not this, but the process of how we got that. And I'll explain that in a minute here, why I want to do it that way. Let's take another example. Let's say we've got $6,000 and we're going to invest $2,221 at one place. So here, what would we invest there? I want the process. How would you do it? What would you do to get it?
Okay, so the same as we did before.
Okay, tell me what that is.
Subtract 2,221 from the 6,000.
Okay, so $6,000 minus $2,221, right? And we don't know what that is, but we could find it. But anyway, that's the process, right?
Right.
Okay, last example here. Let's say we've got $6,000 and we're going to invest X here. How much would we have to invest there? Don't overthink it. Do the same thing you just did.
$6,000 minus X.
Bingo. Excellent. Now, in this case, that's all you can do. You don't know what X is, so you can't make the calculation. You can't go 6,000 minus 2,221 or 6,000 minus 1,000. That's as far as you can go with it, right? Because you have 6,000, you put X here and the rest there. So the rest would be 6,000 minus X. That's where that came from.
Okay.
They had a total of $6,000 And again, they don't tell us that, but I'm kind of getting ahead of things where we're going to end up going. They had $6,000, so they invested X in the bank. The rest was in stocks. That's where the 6,000 minus X came from. Now, 0.04, what's that? That's a 4% interest rate. The time is 1 year. The stocks pay a 6% interest rate. The time is 1 year. Okay. You all right with that?
Yeah.
Now, what's the interest made from the bank? Well, it would be the principal, which is X, times the annual interest rate, which is 4%, times the time. Well, X times 0.04 times 1 would be 0.04X. And again, that's as far as we can go with it because we don't know what X is yet. Are you okay with that?
Mm-hmm.
Now, the stocks, we're going to take the principal, 6,000. Oops. Oh, I got it. I try not to make mistakes on this in this Zoom thing because to use the eraser is more difficult. Oh, well, it's all right. I can do this. Let's see. So this had a bar there. So we're going to take 0.06 times 1 times 6,000 minus X. Okay. So that's what? 0.06 times 6,000 minus X times 1. So let's see. 0.06 times 6,000. Actually, you know what? We're just going to leave it like that. We're going to write 0.06 times 6,000 minus X times 1. Okay, we'll do the final calculations in a bit. All right, so now I've got the interest from the bank plus the interest from the stocks. Okay.
Mm-hmm.
Now, back in the problem, let me read it again. A man made 2 investments that earned a combined annual simple interest of $280. So the combined simple interest was $280. Where did that come from? Well, it came from the bank's interest plus the stock's interest equals a total of $280. So what was the bank's interest? 0.04X. What was the stock's interest? 0.06 times 6,000 minus X times 1. And the total was $280. Okay.
Okay.
So there's our equation. Now, let's go on and solve this equation. First of all, let's clear the decimals. Okay. Now, since there's what? 2 decimal places there and 2 decimal places there and really none needed over there, I've got to move everybody 2 places. So we're going to multiply both sides of the equation by 100, right? 10 would move it 1 place, 100 would move it 2, 1,000 would move it 3. Okay.
Okay.
So now I'm going to distribute. Let's see, let's do this one in blue. So we're going to get, let's see, 100 times 0.04x, which would be 4x, multiplying by 100, moving a decimal point 2 places to the right. Okay. Plus 100 times 0.06 times 6,000 minus X times 1. And let's see, 100 times 0.06, that would make that into what? 6 times 6,000 minus X times 1, which would make it into 36,000 minus 6x all times 1, which is just what? 4x plus 36,000 minus 6x, because all of this times 1 would still just be all of that. Are we okay with what I did there?
Yeah. Mhm.
Then on the right side, 280 times 100 would be 28000. So $28,000. So there's my equation with the decimals cleared out. All right. So
Okay.
now let's continue on. Find my mouse here. And let's go back to black there. Combining like terms, I get negative 2x plus 36,000 equals 28,000. Okay, I'm going to subtract 36,000 from both sides. Negative 2x equals, what's that going to be? Negative $8,000, I think. And then we're going to divide both sides by -2. So x is $4,000. Let's see here. I think that's right. 6 minus. So if we wanted to know how much was invested at the bank, that would be X. So the bank, $4,000. How much invested in stocks would be 6,000 minus X. 6,000 minus 4,000 is $2,000. Are we okay with that?
Yes.
All right, now, if you think this over, you might say, well, if the stocks paid 6% and the bank paid 4%, why wouldn't you just invest it all at 6% in the stocks? That seems like a reasonable question, but here's the deal. The thing they don't mention is that with, what is it in Spider-Man they say, with great power comes great responsibility. I think that's one of the taglines. Well, with greater possibility of profit comes greater risk. So you kind of have to balance between what it's going to pay and what the risk is. Usually if something has a promise of a higher return, there's also a higher risk that you might not get that. But anyway, we'll save that for economics class. All right. Any questions about this scenario?
No.
All righty. Let's go on to this. Let's see here. I have another table I want to look at. Here, this is the runner. This is the walker. And let's see, we've got this, this, this. And it says R times T equals D. And this is a T. It says complete only the time column given that a runner wants to overtake a walker and a walker had a half-hour head start. Let me read that again. Complete only the time column. First of all, this is what? Distance equals rate times time. Or the dirt formula, I like to call it, just there's no I in it, but rate times time equals distance, okay? And they want to know, they just want this thing right here, okay? Complete the time column only. Given that the runner wants to overtake a walker and the walker had a 1/2 hour head start. So if the runner uses T time and the walker had a 1/2 hour head start, what would go in the place of the walker's time? It would be T plus 1/2 or T plus 0.5. In other words, the walker had a 1/2 hour head start and then they were, so the first 1/2 hour was just the walker. The next amount of time was some unknown T. I don't know if that makes any sense or not.
Yeah, it does.
Okay, a little bit fuzzy there, I know, but all right. So let's go on to some other information. By what power of 10 would you multiply by to get rid of the decimal? Would it be by 10 or 10 squared, 100 or 10 cubed?
By 100?
100, correct. Because that would give you what?
8.
8, right? And then how about this one? What would you multiply it by?
10. Would it?
Hang on. To get rid of the decimal. Let's go back here. To multiply by 100, it moved it 2 places to the right. How far to the right do we need to move it? 3 places. So we'd multiply by
1,000.
There you go. Good job. Good job. Okay. Right. Here we go. This says loans. A credit union loaned out $50,000, part at an annual simple rate of 5%, and the rest at an annual simple rate of 8%. They collected combined interest of $3,400 from the loans that year. How much was loaned out at each rate? This is very much like that very first table that we looked at, okay? So let's set up that table. Let's see here. Okay. And total. Okay, let's see what it says. A credit union loaned out $50,000, part at 5%, and the rest at an annual simple rate of 8%. So let's go, we'll call this part and the rest. Okay, and we've got P times R times T equals I. And let me read it again. Oh, they collected combined interest of $3,400. And let's see. Okay, they loaned out $50,000. Part at a simple rate of 5%, and the rest at an annual simple rate of 8%. And it says how much was collected. They collected a total of $3,400 in 1 year. So this is a 1 and this is a 1. Okay, $50,000. Part of it is at 5%, and the rest of it is at 8%. So part of it's going to be X. Here comes the $10 million question. That's not the answer, but what's the rest going to be? We have a total of $50,000 to invest. This is $50,000. We put part was X, what's left? Okay. $50,000, part of it, X went here, what went there? $50,000 minus, oops, minus X.
Oh.
That was that thing we did way back a
Yeah.
while ago. You got it?
Yes. Okay.
Okay. Okay. So there's $50,000 minus X. So far, so good?
Yeah.
So the interest from the part would be 0.05x. The interest from the rest would be 0.08 times 50,000 minus X. And this is all times 1, but times 1 isn't going to change things, right? Mm-hmm. So my equation becomes 0.05x plus 0.08 times 50,000 minus X equals $3,400. Do you see how this is just like this first problem we looked at. So
Yeah.
this one's all a mess. Okay, so what am I going to do to clear the decimals? What am I going to multiply by?
By 100.
Good job. So 100 times 0.05x, which would be 5x, plus 100 times 0.08 times 50,000 minus x, which would be 100 times 0.08 would be 8 times 50,000 minus x. So then we've got 5x plus 200,000 minus 8x. Okay. Notice I took the 100 times the 0.08 first, multiplying left to right, turned that into a whole number. Then I distributed that. And on the right side, 340000. Okay. You all right with that?
Yes.
Combining like terms, negative 3x plus 200,000 equals 340,000. Something's wrong. Why am I thinking something's wrong? Because we're going to end up with a negative answer. So hang on. I am going to pause the recording. All right, we're back recording. The mistake was found, but not by me, by the student. My problem was right here. What's 8 times 50? It's not 200, it's 400. Yeah, way to go, Ben. Okay, so now we're going to subtract 400,000 from both sides. Must be too early in the morning. Negative 3x equals negative 60,000. There we go. Divide by negative 3x equals 20,000. I didn't know where my mistake was, but I knew something was wrong because I was coming up with a negative amount. So how would you invest a negative amount? I guess they'd pay you. I don't know. Anyway, so back to our original question, which said how much was loaned out at each rate. So X, so $20,000 at 5%. 50,000 minus 20,000 would be $30,000 at 8%. There you go. So the moral of the story is I should go back and practice my multiplication. Okay, now I'm going to look at some other problems. Give me just a minute here to get this set up. What I'm doing is a student requested some questions today, but it was stuff that was on tonight's assignment. But it's problems that I was going to do anyway, examples of, so I thought, well, I'll just do her questions as examples. So give me just another minute here. Number 7. All right, so now, can you see the WebAssign screen again?
Yes.
Excellent. And let's see, let's go back to using black ink there. All right, so we're going to take a look at number 7. A professor wants to supplement her pension with investment interest. If she invests $30,000 at 5% interest, how much more would she have to invest at 7% to achieve a goal of $2,410 per year. Okay. So let's make a table. And let's see here. There. P times R times T equals I. Total. Okay. She invests $30,000 at 5%. So $30,000 at 5%, and that's for 1 year. Okay. How much more would she, let's see, so wants to supplement her pension. I'm trying to think of what to call these. I guess we'll just call it first and second. Okay. So the first one, $30,000 at 5%. The second one is how much is she going to invest at 7%? Okay. And the total goal is to achieve $2,410 in supplemental income. Okay. So how is this different from the other one we looked at? Before it was like, oh, we've got $50,000, we're going to invest X here and 50,000 minus X there. This one, it's saying we're going to invest $30,000 here and we don't know how much there. Okay. So now what's the interest from the first investment? 0.05 times $30,000. And the interest from the second investment is 0.07x. So our equation becomes 0.05 times 30,000 plus 0.07x equals $2,410. Okay, so 5% of 30,000 plus 7% of some unknown amount is $2,410. Any questions so far?
No.
All right. Let's clear the decimals. We'll multiply both sides by 100 again. So I get 100 times 0.05 times 30,000 plus 100 times 0.07x equals 2,410 times 100. 100 times 0.05 is 5, so we get 5 times 30,000 plus 100 times 0.07x plus 7x equals 241000. And that's going to be what, 150,000 plus 7x equals 241,000. Now, I did things a little bit differently this time. Before I took this, and then I did this, and then I did this, and then I did this, and then I moved on. This time I kind of went all the way across. It doesn't matter. So now I'm going to subtract 150,000 from both sides. 7x equals what, $91,000. Divide by 7, x equals $13,000. Okay. Let's see here. It says how much more would she have to invest at 7%? So x, $13,000. All righty. Any questions about that problem?
No.
I'm curious here in WebAssign, they've got a $sign by the answer you're supposed to put in, but there's no $sign by the 13,000, the correct answer. Oh, well, what do I know? All right, let's take a look at problem number 9. It says equal amounts, oh wait, yeah, equal amounts are invested in each of 3 accounts, paying 5%, 6%, and 15.5% annually. If 1 year's combined interest income is $1,139.50, how much is invested in each account? Okay. So once again, we've got this table. And P times R times T equals I. And oh, except that we've got 3 investments. So let's see, we'll call it first, second, and third. Equal amounts are invested in each of 3 accounts, paying 5%, 6%, and 15.5% annually. 1 year's total combined interest. What do we know about the principal? It says equal amounts are invested in each of the 3 accounts. So we don't know what they are, but they're the same amount. Okay. So the interest from the first one is 0.05x, the second one, 0.06x, the third one, 0.155x, and the total is what? $1,139.50. So our equation becomes 0.05x plus 0.06x plus 0.155x equals 1139.50. All right. Combining like terms, let's see. 0.05 plus 0.06 plus 0.155 equals 0.265x. Divide both sides by 0.265. 1139.50 divided by 0.265. And we come up with 4,300. So how much is invested in each account? $4,300. All right.
So right here, instead of multiplying by 100, we would only combine the like terms.
Oh, you know what? That's a very good point. I could have done that. I guess because I have a calculator, I didn't bother, but actually, let's go back and let's look at that for just a minute here since you brought that up. I'm glad you did. I should be consistent. What would you have to do if we wanted to clear the decimals on all 3 of those decimal numbers? Would it be 100 or would it be something else?
Well, considering we have 0.155, would it be 1,000?
Exactly. Good job. Because we need to move it 3 places there. So 1,000 times that would be 50x. 1,000 times that would be 60x. 1,000 times that would be 155x. And then 1,000 times this, 1135 or 39500, because it move it over 3 places. So then we get, let's see here, 50 plus 60 plus 155 is 265x equals 1139,500. And good for you for calling me on that. I guess one of the advantages of having a calculator is you don't tend to feel the need to get rid of the decimals so much, but I still should have to be consistent. And there you have it. Okay, good job. I'll be back at 1:15 with an office hour. Let me stop the recording.